What if everything we think we know about electricity is incomplete? What if long before Benjamin Franklin flew his kite, long before Thomas Edison lit up cities, someone in the ancient world had already discovered the secret of electric power? In 1938, just outside Baghdad, Iraq, archaeologists uncovered a small, unremarkable clay jar. It stood only a few inches tall. At first glance, it didn't look revolutionary. It looked like thousands of other ancient vessels buried in the dust of Mesopotamia. But inside that jar was something no one expected: a copper cylinder, an iron rod, and traces of acidic residue. When researchers reconstructed the object and poured in a simple acidic liquid like vinegar or grape juice, it produced a measurable electrical current. Not much, but enough. Enough to power small reactions. Enough to raise serious questions. This artifact is now known as the Baghdad Battery, and if it truly functioned as an electrical cell, it would mean that ancient civilizations understood basic electrochemical principles nearly 2,000 years ago, long before modern science officially discovered electricity. So what exactly is the Baghdad Battery? The object dates back to the Parthian or early Sasanian period, roughly between 250 BCE and 250 CE. It was found near Hujat Rabu, southeast of modern-day Baghdad. The jar itself is made of terracotta. Inside it sits a rolled sheet of copper, forming a cylinder. Through the center runs an iron rod. The top was sealed with bitumen, an ancient natural tar-like substance, insulating the components. In modern terms, that setup looks suspiciously like a galvanic cell, a simple battery. In school, we're taught that Alessandro Volta invented the first true battery in 1800. His voltaic pile used alternating discs of zinc and copper separated by saltwater-soaked cloth. But the Baghdad artifact uses iron and copper, two dissimilar metals separated by an electrolyte. That's the basic recipe for generating electricity. Two different metals, an acidic solution, a chemical reaction. Electrons begin to flow. It's not powerful, but it works. So here's the question that has puzzled historians and engineers for decades. Was this intentional? Or is this all just coincidence? Let's explore the evidence. In the 1940s and 1950s, several scientists built replicas of the Baghdad Battery using the same materials described in archaeological reports. When they filled the jars with vinegar, lemon juice, or wine, they generated between 0.5 and 1 volt of electricity per jar. Connect several together and you can increase the voltage. It's basic electrochemistry. Simple, reliable, repeatable. But here's where it gets complicated. No wires were found with the original artifact, no metal conductors, no lamps, no devices clearly powered by electricity, no inscriptions describing electrical experiments. There's no ancient text from Mesopotamia explaining how to build a battery. So what was it used for? One theory suggests electroplating. Electroplating is the process of coating one metal with a thin layer of another using electricity. It allows craftsmen to make objects appear golden or silver without using large amounts of precious metal. Some ancient artifacts from the region show unusually fine metal coatings. Could the Baghdad Battery have powered primitive electroplating? It's possible. Small voltages are enough for thin plating. But there's no definitive proof that electroplating was practiced in Parthian Mesopotamia. Other scholars argue that the jar may have had nothing to do with electricity at all. Some suggest it was simply a storage vessel for scrolls. Others propose it held sacred objects or papyri. Still others believe it may have been used for medicinal or ritual purposes. In ancient cultures, strange reactions were often interpreted as divine or magical. If someone accidentally discovered that combining metals and acidic liquids produced a tingling sensation, would they interpret it as science or as spiritual power? Remember, Ancient civilizations were not ignorant. The people of Mesopotamia developed advanced mathematics, astronomy, irrigation systems, and architectural engineering. They tracked celestial cycles with remarkable precision. They built cities that lasted centuries. They understood metallurgy. They experimented with chemicals. It is not unreasonable to imagine that someone, somewhere, noticed that certain materials reacted in strange ways. The bigger question is this: did they understand what they were seeing? Understanding electricity is not just about generating a current. It requires theory, observation, measurement, repetition, documentation. Modern electrical science emerged gradually, from William Gilbert's studies of magnetism in the 1600s, to Benjamin Franklin's lightning experiments, to Volta's battery, to Faraday's electromagnetic induction. Each discovery built on previous knowledge. But what if parts of that knowledge were discovered, forgotten, rediscovered? History is not always a straight line. Civilizations rise and fall. Libraries burn. Knowledge disappears. Consider the Library of Alexandria. Consider lost Roman engineering techniques. Consider ancient Greek mechanical devices like the Antikythera mechanism. The idea that ancient people could stumble upon principles later formalized by science is not outrageous. It's human nature to experiment, to observe, to tinker, to test. But there's an important distinction. Accidental discovery is not the same as technological revolution. Even if the Baghdad Battery generated electricity, we see no evidence of widespread electrical infrastructure in the ancient world. No electric lighting, no motors, no telegraphs, no grids, no industrial use. If electricity was known, it was limited, small scale, possibly experimental, possibly ritualistic. Some modern engineers argue that the battery interpretation may be influenced by our own technological mindset. We see copper and iron and immediately think battery, but perhaps ancient craftsmen saw something entirely different. Perhaps the copper cylinder was meant to protect the contents from moisture. Perhaps the iron rod had structural or symbolic significance. Archaeology is interpretation, and interpretations evolve. So why does this tiny clay jar continue to fascinate people around the world? Because it challenges our assumptions. We are comfortable believing that progress is linear, that modern science stands alone, that ancient civilizations were primitive compared to us. But every time an artifact like this surfaces, it reminds us that history is layered, complex, incomplete. There are gaps in our understanding. There are technologies we struggle to fully replicate without documentation. There are engineering feats we still debate. The Baghdad Battery sits at the intersection of science and mystery. It's small, unassuming, but powerful in its implications. If ancient civilizations experimented with electrochemistry, even in limited ways, it reveals a spirit of curiosity remarkably similar to our own. And if they didn't, if this object was something entirely different, then it still teaches us something valuable. It reminds us to question, to investigate, to test assumptions, to avoid projecting modern knowledge onto ancient artifacts. In the end, the Baghdad Battery forces us to confront a deeper question. How much of history have we truly uncovered? How much knowledge has been lost to time? How many discoveries were made, forgotten, and made again? Electricity today powers our homes, our cities, our communication, our world. But perhaps in a quiet workshop 2,000 years ago, someone noticed a spark, a faint reaction, a strange effect between metals and liquid, and for a brief moment in history, ancient hands held the first whisper of electric power. Whether they understood it fully or not, we may never know, but the mystery remains, and sometimes the mystery is what keeps history alive.